I love neural radiance fields and Gaussian splats. This is a way of taking lots of images or a video taken at multiple angles of a subject and using AI to create a photorealistic 3D scene. And for those of you that are familiar with photogrammetry, we can see how this is far superior, especially when it comes to rendering reflective surfaces like water. It's also pretty good at capturing small objects in a very short amount of time. I use Gaussian splats and neural radiance fields quite a lot in my work, so I was super excited when Tim Gerritsen brought out a TouchDesigner component that allowed for working with Gaussian splats within TouchDesigner. The only problem for me is that because I'm on an M1 Mac, I wasn't able to access the color data from my models in the component itself. We can see here how the model is loaded in, but I'm not able to actually see any of the color. I was able to go into the GLSL and I made some small modifications that allowed for me to actually view the color as well. I wanted to share it because Gaussian splats is just a really nice way of bringing real-world material into the 3D world, and particularly having something that's real-time in TouchDesigner is a great thing to play around with. I'm not sure if other people had encountered this issue on M1 and M2 Macs, but I wanted to share my update of the component just in case people wanted to play around with this who had some issues. We have a few objects, so we've got this Gaussian splat geo, and this is where we would add different models. Gaussian splats are quite complex files, so they can sometimes take a couple of seconds to load, but once they've rendered, we can manipulate them in the panel view by rotating them in 3D space. We can also hold down the Option key and zoom, and we can pan left and right as well. So that's the camera operations that we can use. In the geometry component for the splat itself, we have this uniform scale, which acts as again a zoom, a dolly. We have splat size, and we can really think about it in this way. When we go really close to an object, we can see that the image itself is built of these overlapping shards, which are essentially sort of elongated 3D long ellipses essentially. And when I start reducing the splat size, these splats reduce in size, so we can start seeing the individual almost points of that image. And as it gets sparser, we can see that the frame rate goes up, and this is because we're rendering less information overall. So if you're on a slower computer and you're trying to render something a little bit faster, finding that sweet spot in reducing the splat size can always help. Something else we can do is play around with the alpha threshold, and this is essentially, we can think about this as a threshold of how many splats are going to be drawn to the screen. So as I start moving this up, we can see that the image itself becomes sparser, and after a while we can see the direct geometry of what these splats sort of natively look like. They're sort of these squished circles and ellipses, and this could be quite a cool effect in itself, but for the photorealistic types of imagery, you're going to want to have a pretty low alpha threshold, but this is all stuff you can experiment with. In the camera viewport itself, we have a few things. You can change different views, but really the coolest thing to do is just turn on this auto rotate so you can rotate. In terms of like specific operations that you might want to do with the Gaussian splat itself, this is the internal guts of that Gaussian splatting render component. And we can think of this a little bit like how we might manipulate a point cloud. So if you added in a feedback loop or any kind of method of how you like to manipulate points, you could add it in here and create something quite interesting. So I hope this is useful. I'm uploading this to GitHub, and I'll attach the link in the comments. And feel free to download it and use it in your work.